Today we will analyze arithmetic sequences and series. In an arithmetic sequence, consecutive terms have a common difference, and we denote this difference with the letter D, lowercase d. This common difference can be a positive or negative number. For example, 1, 4, 7, 10, we continue to go up by 3. So notice we have a common difference. Here's another example where the numbers go down by 4. So in this one, we have a negative common difference. So you'll notice that common difference can be positive or negative. Alrighty, let's look at example 1 and see if these are arithmetic or not. So here I can see I'm going up by 4, up by 5, up by 6. I see a pattern, but this is not arithmetic because that difference is not common. Okay, let's look at the next one. We're going down by 3, down by 3, down by 3, down by 3. So this one indeed is arithmetic. We have a common difference. Alrighty, let's see here. We're going up by 2, up by 4, up by 8. Definitely not common, but notice, well, I'm not even going to cross that out. This is not arithmetic. But what we're going to find in our next lesson is that this is geometric. We multiply by 2 each time. And that's going to make this what we call a geometric sequence. Okay, now, I told you last time that I'd show you how to write a rule or a formula. And here's how you do it. The nth term, also known as the general rule or the formula, anything like that. But you'll notice we usually call it the nth term. Is denoted by a sub 1 plus n minus 1 times d. And notice there are parentheses. Some people like to put the d in front of the parentheses. It's your preference. This is the one that you'll see in the textbook. Alrighty, so for this example, the first thing I want to do is see if it's arithmetic. Because in order to use this formula, it must be arithmetic. So I'm going to add 4, add 4, add 4. Indeed, this is arithmetic. So this says find a sub n. This is just saying, what's the 6th term? So that's the 1st, 2nd, 3rd, 4th. The 5th term would be 19, and the 6th term, if I go 4 more, would be 23. I don't need a formula for that. If it's a low number that I can get to really easy, I don't even bother with the formula. But for part B, this is saying find the 93rd term. I don't think I want to write that out. So I'm going to use my handy dandy formula. So a sub 93 equals the first term, which is 3, plus n, this is n, okay. In the parentheses, I'm going to put 93 minus 1, and then d. D is my common difference, which is a positive 4. So at this point, you can really just punch this into the calculator. 92 times 4 plus 3. So 92 times 4 plus 3 gives me 371. Okay. Now, I asked for just a sub n. So now I'm just saying, what's the general term? What's the formula for this particular sequence? So now what I'm going to do is I'm going to write a sub 1 is 3. And where the formula asks for n, I'm just going to write n minus 1. And our d is 4. So now I'm going to simplify this. You must. So I'm going to distribute, and I get 4n minus 4. Combine like terms, I get 4n minus 1. So, final answer. Alrighty. And now, just notice I could plug 93 in here and do 4 times 93 minus 1, and that would give me the same answer. So once you have a sub n, you can plug any number in that you like. Alrighty, let's look at a new sequence. We have 2, 5, 8, 11. Let's go straight for a sub n. First, let me make sure this is arithmetic. Yes, my common difference is 3, so D equals 3. Now, my formula is A sub n equals A1 plus n minus 1D. And so now A1 for this sequence is 2. N is n, and D is 3. Just like before, we're going to simplify. Combine like terms, and I get A sub n equals 3n minus 1. Minus 1 again? Okay. So now I'm asking you to find A sub 100. I have a choice. I can plug into this formula, or I can plug right into this formula. Okay? And that's definitely where I want to go. So A sub 100 equals 3 times 100 minus 1. So that's just 299. All righty. Now, let's talk about series. We've looked only at sequences. Let's see what it means to be a series and to have a sum. So, we use a capital S to denote sum. Okay, capital S. So, here, the first thing I want to do is check to see if it's arithmetic. If it is, I want to see what's going on. So I'm going down by 3, down by 3, down by 3. Seems like we just saw this sequence. Okay, so it is arithmetic, and we're going to use this new formula, which says the number of terms times the quantity of the first term and the last term divided by 2. And that's how you find the average. That's an average. And so we're just taking the average of the first and last times n. So the first thing says find S sub 5. This means the sum of the first 5 terms. Now, I'm going to say this. We don't need a formula to add up 5 numbers. This would just be 8 plus 5 plus 2 plus negative 1. Let's see, that'd be what, negative 4? And a negative 4. So what is that? 15 and negative 5 is just 10. I wouldn't bother with a formula for that. Okay. However, if you look at part B, I asked for the sum of the first 58 terms. No, I don't want to write that out, and I don't want to add that up. So I am going to use this formula. This is 58 is n. So this is saying what's the sum of the first 58 terms. Now I need the first term, which is 8, plus the last term, which is I don't know what. I got to add it up to see what's the 58th term. And so you have to find a sub 58. And so that means I got to go back and use the other formula. So this is what you always got to be aware of. That's a big warning sign right there. Caution. You have to find a sub 58. See, n is 58. So I'm going to go to my other formula. And that is A1 plus n minus 1 d. And d is -3 for this one. And so that's 8 plus 57 times -3. And don't forget your order of operations. So you have to multiply first and then add the 8. So that's -163. Now that's the value that I'm going to drop over here. -163. And again, beware of your order of operations and everything, and make sure you don't mess up. And you know what I like to do? I like to just cancel that in there and say 2 goes in to 58 59 times. So I don't even have to worry about that. Okay, so now I'm just looking at 29 times 8 minus 163. Drop that in the calculator, and you get -4,495. Alrighty, example 4. In our last lesson, I promised you we'd look at what happens when there's a big number on the summation. Well, if it's arithmetic, which looks linear, okay, then that means we can just use the S of n formula that we just learned. The first thing you might want to do, though, is try to understand your sequence or your series that you're working with. If you plug in 1, 6 times 1 minus 2, that's 6 minus 2 is 4. That's your first term. If you were to plug in 2, 12 minus 2 is 10. And I just want to make sure you understand what's going on. This is your common difference. The numbers are going up by 6. Okay. So you can always see if it looks linear, the slope is 6, that's the same as your common difference. So this is what's going on with this problem. But let's go ahead and use our formula. S of 84. We have 84 terms. And then we're going to do n times, let me write the formula right here for you so you can see it again. A1 plus A sub n over 2. Okay, so A1, that's our first term, is 4. And our last term is A sub 84. So I have to go figure out what A sub 84 is. But I don't have to go back to the other formula because guess what? This is the rule. When you write summation notation, this is the rule. This is the nth term. Okay, so all I have to do is plug 84 in there. Okay, so once I plug 84 in there, I can plug that right on in, and that's 502. And again, if this first number is even, I just like to divide that in, and then I don't have to worry about the fraction. So I have 42, and 4 plus 502, or 42 times 506. Punch that in the calculator, and it's pretty juicy, but I'm sure you expected that. That the sum of these 84 terms would be a big number. Now I want you to look. I just said that there are 84 terms here. Okay, 84 terms here. So, how many terms are there in example 5? Notice we didn't start with the first term. So we're going to plug in 3, then 4, then 5, then 6, then 7, all the way to 34. Now, most students would say, oh, Miss Adams, that's just 34 minus 3. That's 31 terms. But I say you're wrong. Okay? If you look up here, there's 84 terms. But if you were to do 84 minus 1, you would get 83. And you may learn if you take some general counting principles, and actually later in the year, we'll do a little bit with probability and permutations and stuff. You always have to add 1 to get back to where you started from. Okay? For example, if I ask you how many fingers that you have, you wouldn't say the first number is 1, the last is 10, 10 minus 1 is 9. You'd have to add 1 back on to get to 10. I hope that makes sense. So here, 34 minus 3 is 31, but add 1. There's 32 numbers here, okay? So we're looking for the sum of 32 numbers, okay? So this summation, and actually you don't even have to worry about that. You just want to know the number of terms is 32. And the first term, you're going to plug 3 in. So we get 2 times 3 minus 3. 6 minus 3 is 3. And then we're going to plug in 34. And that's our last term. So 2 times 34 minus 3. 68 minus 3 is 65. So we have our first term and our last term and divided by 2. And yay, this is even again. So we got lucky. So then we're just going to do 16 times 68. And I'm going to grab my calculator. 16 times 68 gives me 1,088. And our final example for today, write a rule for the nth term of the sequence where d equals 5 and the 11th term is 43. So what we're going to do here is we're going to start with our formula for the nth term, which is a sub n equals a1 plus n minus 1 d. Alrighty, and we're going to fill in everything that we know. Well, we know that a sub 11, we don't know what a sub 1 is, but we know what n is. N is 11. And we know what d is. D is 5. So at this point, we can solve, okay? We're going to solve for our one unknown. Because to find the nth term, all you need is a1 and d. This is what you need. We're only missing the a1. So a sub 11, we know is 43. And that's 10 times 5. So that's 50. So I can subtract 50 from both sides. And I see a1 equals -7. And now I can go back to my formula now that I know a1 and I know d equals 5. I can write my nth, my a sub n. So a sub n, remember that's a1 plus n minus 1d. And now we can plug in a1 and d. So a sub 1 is -7. We just found that. We're leaving n alone, and d equals 5. Distribute. And I know today's lesson is a little long, but you can handle it. So here's our general rule, our nth term. A sub n equals 5n minus 11. When I do a problem this long, I always like to go back and double check it. The original problem said a sub 11 is 43. So I like to go back and check a sub 11. I like to plug the 11 into the formula and see if it really works. 55 minus 12 is indeed 43. So I feel pretty good. I double checked it. You don't have to though.